Good night, Asia.
Good night, sir. Sorry for my absence last class. Didn't have any
Oh,
internet.
okay. I was wondering. All right, no problem. Just waiting until the others join. So you another few minutes here.
Okay.
Mhm.
Good night, everyone.
Good evening.
Good evening, sir. Good evening, everyone.
Good evening.
Hi, Michael. All right. I think that is enough time for you to look at the water cycle. Um, Asia, Karel, I'll give you an opportunity to go through. Mike and I had the pleasure of doing this last class. So I'm going to ask, just look at it and explain the process as we look at as we go around the cycle. Okay, so maybe I'm muted because,
No,
Oh, yeah.
sir.
okay. Somebody start now, please. One of the two ladies start, please. When you stop, you call upon the other one to help you. The
Okay.
information is in front of you. It's just for me to explain. Mike and I will
What?
listen. Go ahead.
Okay, sir. So,
Sorry, hold on. My hand touches the cool.
so when you say anything specific, like what it is and such?
No, I want to explain the cycle. Look at it and explain it. Tell me what is
Oh,
happening. Yeah.
so as you can see here, there's okay, explain.
Where would you start? Where would you start with the explanation?
I would start at evaporation.
Okay.
Okay, so as you can see, this is the water cycle showing the movement of the water through the earth, including the atmosphere. Sorry if I sound a bit congested. I'm in recovery mode right now.
Hush.
Okay, so the first, I would start by explaining the evaporation process, which is one of the stages of the water cycle. So during this process, it's in the name evaporation. So the sun heats the water, heats waters like the lakes, the rivers, the ocean. Even though we cannot see it, some of it goes up, evaporates into the atmosphere, turning into what we call water vapor. And as I said, it goes up, it rises into the atmosphere. And then the second one, following that, would be condensation. And in this one, as the water vapor would rise and go up into the atmosphere, we heard this term before, it cools and condenses into droplets and it start to form clouds. And then we have Asia, you want to help me out?
Where from? Which are the transpiration where?
Yeah.
So continuing from transpiration, it's basically similar to evaporation, where water is like how can I say it's evaporated from like the surface of plants and so. and into the atmosphere. And this transpiration or the water from the plants is absorbed or evaporated and goes up into the clouds where we have our formation of clouds where we can release water by rain, which is rain, it would be precipitation, but it's not shown here, but that would be precipitation over there. Alright, so it forms the clouds and it can fall as snow. And then we'll have our deposition, which is snow and ice. So I guess this is where the ice or the snow falls, just like the rain would fall as precipitation, I'm guessing. And we have our precipitation where we have rain, snow, fog, and hail falls onto the earth, falls onto our plants in our communities. Then that rain is absorbed into the soil, which is our infiltration, can flow, which the water flows or is absorbed into the ground and into our groundwater, and then it leads to percolation, which would be similar to our infiltration, where it facilitates the water movement through the soil, or where infiltration is in the soil, in the groundwater, which leads from the groundwater into our lakes and our oceans, and I guess other parts where it leads from like mountain tops, it leads into the ocean as well, and then the cycle restarts through evaporation.
Why did you start? Why? Okay. Carl started at evaporation. Would you start at the same place?
I guess you can start anywhere since the cycle is not really the definite start or ending, since it's a big circle. But if I were to explain, I would have started at evaporation as well.
Mikey,
So
where would you have started?
oh,
Go ahead.
I was going to ask, so where would you start, sir? Because I know some people also start at precipitation as well.
Where would you start, Mikey?
Sir, I would start from.
And I'm not suggesting that she's wrong, you know. I'm not
Yeah, I
suggesting that.
know.
Right. But
I
where would
would
you
start
start?
from evaporation, either evaporation or precipitation.
Okay. By
I would
precipitation.
start from evaporation. I would start more from evaporation because that's basically the foundation
No, it's the
to the
source. The
cycle.
source. The source. The source.
The source to the cycle.
Very good.
Yeah, because without the evaporation, then
You can't have
the
precipitation.
cycle can't start. Exactly.
Absolutely. Absolutely. So so when I ask a question, it's not for me to say that, oh, you're wrong. It's just for me to see if you are thinking, because I can't start, I could either start from evaporation or transpiration, right? One of the two. But I can't start at condensation. Yes, when it's a cycle. But I can say oceans, the rivers, streams, lakes. The sun has an important part, because if the sun is not out, the rate of evaporation, transpiration is going to slow. All right. So the sun, I didn't hear anybody talk about the sun really in the explanation, but the sun plays an important part in this process, a very important part in this process. So important that it is as a result of the sun why we have the evaporation and transpiration. Right? So the sun is going to, go ahead.
So, the diagram might not like say, but based on science, based on the science of evaporation, there must be an
Mhm.
agent like wind
Mhm.
because like yeah, the surface flow, the movements of the cloud because though you have the condensation happening in one area, the precipitation doesn't happen in the same area that the condensation
Mhm.
happens. So
Absolutely.
yeah, so though it's not there, wind is a major factor, and wind is also an agent that allows evaporation because wind is the horizontal movement of air. So that in itself influences evaporation and evapotranspiration.
But remember, for evapotranspiration and evaporation to take place, remember, it's a change in state from a liquid to a gas. It's a change in state, from a liquid into a gaseous particle or gaseous particles. And it's just those gaseous particles now that is transported through the atmosphere. So evaporation takes place from many different sources. You have a puddle of water on the road. It rained today, heavily, might I add. If that water body is not percolated and infiltrated, come tomorrow morning, we're going to have puddles of water on the road. When the morning sun comes out, in Kingston, where we don't have no beaches, no ocean, and no river, no lake, it is a puddle of the water that is going to form the basis of the evaporation. Can you see that?
Repeat what you just said, sir. Repeat.
Now I'm saying to you, it rained today heavily.
Yes, sir. It did rain today.
Mm-hmm. So if you don't have percolation and infiltration taking place fully, or the sun is super saturated, tomorrow morning we're going to find puddles of water on the roads, true or false?
True, sir. True.
Mm-hmm. We don't have any rivers and streams in Kingston. So what will facilitate evaporation will be those puddles of water that will find around Kingston. And that will be the source of our evaporation. When early morning sun lick it and the gas particles the water becomes hot, it starts to, the sun hits the earth the earth is always giving off heat, and you will see why a little later on. When I look at the lithosphere and show you that core, the amount of heat that is generated within the Earth's core, all of that travels to the surface. So the puddle of water on the roads are pretty much getting hot and increasing in temperature. They may have a bubble moving from the bottom because remember, boiling takes place throughout the liquid. The evaporation takes place at the surface of the liquid. So you may have a bubble or two coming through the liquid. When it bursts at the surface, that is the time it is releasing the gas particles. That's the time it releases the gas particles. And when it releases the gas particles, now the gas particles move. So if the wind is going, it is moving, or it's just floating through the air. And it goes all the way up and fill the clouds as water pockets. The mere fact that that water bubble is escaped at the surface of the water, it means that I have one water droplet less. And as the sun continues to blare down on it, more and more bubbles are moving through the liquid, bursting at the surface, releasing more gas particles and more, and every gas particle that the bubble releases, you have less water settling. And this process continues until the water itself is all consumed, all evaporated. All right? Now, condensation is a process that we move from, anybody can remember?
After the concentration?
Condensation. What condensation does?
Convert water vapors into water droplets.
From gas to a?
Liquid.
You have to remember those things, you know, because Teacher Shan went through all of those stuff with you. And why Teacher Shan had to go through those stuff? Because Teacher Shan knew that he was going to get to this portion of the syllabus. Right? So what happens is condensation takes place, moving those gas particles into water droplets. Those water droplets now fills the cloud and continues to fill the clouds. Your neighbor has a swimming pool. Water is evaporating from the swimming pool as well. You have a little water stored on the outside in a water tank. Believe it or not, the water tank, even though it's covered, the sun hits that water tank, the rhino water tank, and it gets very hot. You have gas particles escaping through the lid of
the rhino tank them you talk?
Yes, ma'am.
Oh, them tough tank there, sir?
I'm may to tell you.
No.
You ever whatever gone it and you turn on your pipe and it use up water from the tank and it hot like it just took off of the stove?
Yes, sir.
Yeah, man. You can't well, it's very difficult for you to have a shower sometimes in the middle of the day because you remember the tank is dark in color, you know, and it traps the heat.
Yes, because black naturally.
Yes. So what happened now is that the gas part, remember gas, you know, when the gas want escape, the gas are going to escape by whatever means. By whatever means, right? It's going to push on top of the lid. And if they have enough gas particles pushing on top of the lid, it is going to push the lid open. It's going to push the lid open. And sometimes when you look on your lid, you recognize that it is warped. You know what I mean by warped? And it can't cover so good again.
What do you mean, like it melt little bits because of rubber?
Absolutely.
And then it can't cover proper, it can't go back the same way it go back on.
Absolutely. So you're following what it is that I'm saying. Right. All of that is as a result of the gas particles at times pushing against the stuff and pretty much changing the shape of it, right? So when the lid can't close properly, you have more gas particles escaping. Those gas particles are also getting into the atmosphere, to be condensed for the water vapors to convert from the liquid to the gas. And all of those are now stored in the clouds. Now, evapotranspiration. As Mike and I had a little one-on-one last week, Thursday, one of the things that I do, and I'm explaining the water cycle. This is the last time I'm explaining the water cycle. And then we're going to move into some other stuff. One of the things that I do, as I should have done it today, but because I had meetings, I just aborted it. I should be no, but can't bother. I wanted to unload the machine, but guess what? When I load my machine, it is not a common practice of me to allow the water to go into the septic, because all I'm doing is just filling up the septic. Funny enough that we're having this conversation. So I had an exec meeting today, and one of the vice principals was presenting that they need to call the cesspool emptier people, because one of the septic at school is, we see evidence of it overflowing. And of course, that becomes a health hazard now, right? So they actually came and emptied it. Yeah, they actually came and emptied it. And I smiled to myself because I remember Mike and I had this conversation on Thursday. And in the exit meeting, I was able to offer some solutions to them. And the solutions that I'm offering are solutions that are environmental in nature. All right? Now, life is a cycle. Some of us go on stushy, but we don't recognize that life is a cycle. I'm not going to tell you about that one until I reach infiltration. So when I'm doing my laundry and the machine is extracting, that hose is removed from the drain, and I have a plastic barrel on the outside that I strip. Matter of fact, you know what teacher do? To show you how deliberate I am, I went to the hardware store and bought an extension hose and bought a clip and fasten it together so it don't leak. And I have a longer hose than the one that I got with the machine. And I stretched that into a drum outside. And one of the things that I did to that drum was to, use my flat bit, drill a hole, attach a pipe cock to it. So now it is I can turn on and turn off. There is a hose connected to that. And when I'm doing the laundry now, it is connected and the hose is thrown at the roots of different trees. And when that is saturated with lawn, because am I going to be using potable water for irrigation purposes that I have recyclable water to do all of that? One of the things that I said to them in the exec meeting today is that when they are complaining about the students clogging and I want you to listen, because this is going to be one of your solutions when you get out into the world of work. They're complaining that the students are using way too much toilet tissue and clogging the toilets, and there was an overflow with an upstairs toilet some time ago or recent, and they had to remedy the stuff. And I said, okay, fine. And I said to them, why are we sending the gray water into the septic and then turn around to use a potable water to irrigate the lawn? I said all gray water should be used for irrigation purposes. And no, I don't know if they were understanding what it is that I was saying, but I offered another solution. I said to them that the bathroom facility on Block B could be used to irrigate the section between Block A and Block B, could be used to irrigate the section across from Block B. It could be used to irrigate quite a bit of places. And then no, the place will be a little bit more green, and we don't have to worry about using our potable water for the stuff. Well, they accepted it, and they saw where I was coming from. All right. So when I water those plants, and it is customary for me again, I don't water the plants, I want to water the root. Me wet the plant under the leaf because that's where we have the evapotranspiration taking place, you know. I do it under the leaves, especially them the banana, top and bottom. And trust me, make our water run good straight in the middle of it. All right? So you water the stuff because guess what? When the sun comes, transpiration is also going to be taking place. You're going to have water molecules leaving the surface of those leaves to go up into the clouds to fill those clouds. So you know your ocean, your rivers, your streams, your lake, and just bodies of water. Bodies of water. And then when you have the evaporation taking place, you have the condensation taking place, and then you have the transpiration taking place. Those are terms that you must, when if you are given to explain the water cycle, these are terms that must come up into it. All right. Now, the water droplets that are evaporated and are moving around, that transportation is a movement of wind that is carrying those water droplets to other places. So don't think that if I have a body of water on the floor here, that means on the ground, it means that the water molecules, the evaporation is going to take it to the cloud that is perpendicular to it. No. By the time that water vapor leaves and it is in flight, and the wind comes and blow that, it may blow it in such a way that it catch from Mountain View, it may catch Stanton Terrace. And then for it to continue above the person who are you following me?
Yes, sir.
Yes, sir.
All right. So we have transportation. And the transportation is being carried all over the place. All over the place. And then we have the position. It's when the clouds get filled up and them clouds are burst open. We will have
Sir, repeat.
when the clouds get filled and then burst open, what happens?
Precipitation.
Rain.
We have rain.
Rain.
We have rain. But guess what now? You ever wonder why sometimes it's all a rain up at the top of your avenue, but down at the bottom of the avenue not getting a rain, or in the middle of the avenue not getting a rain? You ever see that yet?
I always thought that only the clouds that are filled rain come from. So rain the clouds
Like
never
the one
descend
them
before
went dark.
Absolutely. No, but you only thought, you don't need to think, because that's exactly what happened, which is the point I'm now making. So immediately above the top houses on your avenue, you may have dark clouds, suggesting that the clouds that those clouds are filled. But by the time you look down your yard, you recognize your yard, everything clear, clear, clear. You're not gonna have no rain in your yard. Only rain go to up avenue. But guess what? Even though it's not raining by you, the wind will carry water droplets and drop at your foot. Because like all Hurricane Gilbert, the rain was coming horizontally, You know what I mean? Horizontal?
Sir, sideways.
Yeah, man. Dangerous. Dangerous. Because of the wind. So when the rain, when it falls, when the water droplet falls, and the wind start to pick up, it blow away the vertical fall of the rain. And they have that horizontal movement. Dangerous. Lots of infrastructural damage to property takes place with them type of rainfall. Lots of flooding, more flooding. But what do you mean by that, sir? Water get for blowing a house now. I don't know if they have demystified this myth that when you're having like a heavy winds, hurricane type winds, and you have that sort of horizontal flow, they normally say that you need to open your windows so that the wind actually blow right through your house. Because if the wind blows, gets inside of your house, but your window, your other windows are closed, are your doors closed, what do you think is going to happen? Come talk to me, man. You're final year students. What is going to happen? Atmospheric pressure going to increase in your house, don't? Talk to me now. Yo,
Yes, sir.
Yes,
talk to me
definitely.
now.
Yeah, the pressure will increase in your house.
And then what is going to happen now? Because of that atmospheric pressure being increased, it is going to put pressure on your roof. And as come the man, them roof blow off in a hurricane.
You
It's
mean
all
the
the other
zinc?
day when, yeah, it could be zinc alone. Zinc alone, could be zinc and it could have, well, the slab, of course, is not going to move. It could be zinc or shingles, so, well, yeah, and if you want to get technical, you can say, but sir, shingles is made out of zinc, but, well, you have the wooden and the metal one, but yes, it's just going to pressure the roof. And if it is not properly strapped, it's going to go. It's going to go. And that's why during burial, you see on social media, the people, them literally um, strap their houses to the ground. Them drill deep down and put steel deep down and use belts to run from the front of the house all the way over to the roof and strap it to the back of the house so that it's preventing. Matter of fact, if I pass there tomorrow and they have it, I'm going to take a picture and send off to you guys. there's a house down East King's House that they strapped it. They put on a belt um, from one end of the, like from the front of the property, and they run the belt on the roof and connect the belt to the back of the property, tighten it so it keeps the roof down. It's just one of the ways to mitigate the loss of the house. So I don't want you to underestimate the transportation of the wind. Moves. The deposition forms snow and ice for those areas that it snows. The snow melts. And what happens when the snow melts?
Runoff.
You have the runoff into oceans and streams. You have the runoff in oceans and streams. When it gets very hot, do you recognize that water level rises? Why?
When it gets hot, very hot?
Mm-hmm.
No, sir. I didn't. I would thought it would get like the water level would be low
Why?
because it's hot. Very hot.
So you have evaporation taking place.
Yes.
All right. So this happens now when it is that you are in those glaciers, because the time gets so hot because of the whole depletion of the ozone layer, you have more break off of ice. And the ice itself, the break off of the ice itself falls into the ocean. Now it becomes it's heavy. So it's not something that, yes, you're going to have some floating, but you're going to have, and the break off of the ice is not one little chip off something, You're talking about massive break off. So all of that now, what it does, it falls into the ocean. It is melting, falls into the ocean and causes the water to rise. And as a result of that, sometimes oceans, burst their banks. Rivers, lakes, because there's just an overflow. Yes, you may have the loss of water by evaporation, but sometimes one process supersedes the other. It's like you have a bank account. You're adding money to the account and also taking money from the account. So you may say, yeah, everything good. But you may be taking out more from the account than you're putting in. So nothing can good.
Yes, sir. I understand that, sir.
All right, good. Now, then you can have the precipitation. The precipitation is going to be your rainfall, your hail, the fog, um, the melting of the snow. You can have that water coming back down. It's coming back down to fill back the lakes, fill back the ocean, fill back the rivers and streams. So you see how cyclic it is? It leaves, it does something, and then it comes back around. Now, what happens, what is very important, is that when it hits the lithosphere, you will have infiltration taking place. You're having infiltration taking place. No, infiltration. I love Florida. It is my go-to state, particularly because it's an easy hour and a half. Easy hour and a half. One plane. Can't bother we have to take off plane and no little plane and then black out helicopter go come crash. No, sir. One little something from Jamaica and reach right this. So to be honest with you, I don't even want to go further. I'll go further if I go jump on one explain. But one of the things that I keep talking about Florida is that Florida has lots of sand. I know where my people them live in Florida. You go to the start dig up here, sand. You're getting so which is why if it rains as it did like last summer, heavy, heavy, heavy rain. Heavy rain. It's by the time the rain subside, you can walk out the door and have no mud up on your foot because you don't have enough water settling really. So the infiltration process is very good. So this is a reason now they're saying that Florida soon wash away. Florida soon wash away. Why? Because you're now touching the liquefying the soil. So it starts to flow. Does that make sense?
Yes, sir. I can see it making sense.
Yeah, man.
Yeah, man.
So geologists or earth scientists are watching Florida because if Florida ever get one serious storm, many other places are gone. So, and then now, so we have infiltration, then we have the percolation. The percolation is what is going to cause the movement of the soil. Let me tell you something. You see, some of we're going to stushy and we not do this and we not do that. Let me tell you something. Anybody knows how a septic tank is built?
No, sir, I don't.
Yeah,
Okay.
man.
I know you know, Mikey, but Asia, you know what a septic tank is built?
No, sir, I don't know.
Mikey, just run through for me and just tell them what is a septic tank and how, what the man them doing out of to build it up.
All right, so septic tank is basically a wastewater treatment facility or system. So it has some of them are divided into sections, some of them are just a single unit, single chamber. But you really want more than one chamber so you can have proper separation of your solids that you come so that you can have like cleaner water in each as it passes through each chamber before it discharges to the environment. So it's normally made out of concrete or plastic, preferably concrete, which lasts longer. And you don't have to you don't have to set up your dilution rate. You don't have to calculate all of that. You have to do that with plastic because the plastic will literally implode once you cover it up. It will start to implode at itself. But it's made, you have your sections, it's connected to your house. It's normally connected to where you get your black water, that is your sewage from your toilet. And it basically separates those solids from the water. So the solid settles to the bottom. And the fat, fat and water don't mix, so it will float on top of the water. And then within that chamber, you have your bacteria working on the organic matter. So you don't have a build up, breaks it down, and then as the water rises, it flows over to the next chamber. Any remaining solids are settled, and the same process happens where you have your bacteria, actually your bacteria working on the organic matter. And by the third chamber, it's supposed to be cleaner, and that water now can be sent to either a tidal field where it's absorbed by plants or a soak away. That's a general idea of it.
Yeah, good. Two things though. My other contribution as the environmental person on the exec today is that they need to get some bacteria bacteria to flush into our toilets. So it is that it can help to break the solids down when it gets into the septic. And for the life of me, I just couldn't remember the ones that I normally use, the brand that I normally use. Anyhow, I found one and showed it to someone and said, yes, this could work. And then I kept looking and then I found mine. Ridex is the one that I use. And what
Oh,
Ridex
yes, sir.
is
I heard
it's
about that.
yeah, man, it's like a sachet. The one that I found, the first one I found is like, you know those toilet bowl cleaners, blue toilet bowl cleaners drop in the thing, the Clorox or the Clorox, the blue one and the green
Yes,
one, you just drop it
sir.
in the tank,
Yes,
the toilet
sir.
tank, and after every flush it, you see the blue, right? So one of those is something similar to that. So you will put it in the in the tank itself, and every flush you flush, you're gonna have a portion of the bacteria that is released into the tank, into the bowl. Flush the stuff, and as it goes, the bacteria is actually breaking down your solids, breaking down the solid. The solids now will, when it gets into the septic, forms as like a sludge, and it falls to the bottom, and that now becomes solidified. So over time, technically over time, your the volume or your capacity of your septic is going to be reduced because you have the solids that keeps building up. Remember, Michael just spoke about different chambers, because the solids are going to be building up and building up and building up. So technically reducing stuff. Case in point, the Mona Reservoir. When you have heavy rains and you have water moving from all the way up Mavis Bank and going through the aqueduct and coming, man, and filling up the water tank, and NWC say, yo, 100% capacity. Lies. Lies, 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 lies. So when they're going to come and say, oh, we have 100% capacity of the stuff, what the NWC must also say to you is that the capacity of the dam has decreased. Can anybody tell me why it decreased?
Yeah, what built up is in a sediment deposit at the bottom of the dam.
Yes. Siltation. You're going to have siltation there. And trust me, siltation, it becomes calcified. It is like concrete. So it's not that you can say, oh, let us use a vacuum at the bottom of it and we're going to suck out to something. No. And that is a problem now with the Mona Reservoir. Because in order for you to remove that heavy siltation, you have to go drill. And they believe that if they start the drilling, you're going to crack the tank and it's going to compromise it. And then now, boom, we don't have any storage. So that's a challenge that the National Water Commission is facing. So I don't know. I can't tell you what is the capacity. But if the original capacity, say, for example, just using a random number, 100, 100, let us just use a random. If it is 100 gallons, over time, that the capacity, because of the siltation, I think about maybe 40% of the siltation that has been built up. So even though even though we have the tank is filled, we may only have 60%, only 60%, because we may have all of those, the siltation is going to eat up the volume of the other part of the tank. So so siltation is very important in what it is that you're doing. One of the things for me is so where I live, whenever it rains and rains heavily, don't wash no clothes because your clothes will turn brown. You try make sure the water run off quite a bit before you decide to even start washing. Matter of fact, if you go water fresh, don't stand up under the pipe and open your eye under the pipe, because the turbidity of the water is heavy and you have lots of sediment coming from. And then now you open your eye and you're getting these little sediments inside the eye and start rub your eye and you rub one of those sediments across your iris. And then they say, so me now see so well, Yeah, because it damage your eyes. I remember one Christmas, as we speak about the water, one Christmas, a family member was using one of the bathrooms, having a shower. And the next thing I heard is one big scream. When I ran to the bathroom, I recognized that the pipe couldn't turn off. And the water was just gushing, gushing, gushing. I said, all right, don't worry about it, man. Finally lock off. Finally lock off and lock it off and say, here's the plan. We got abandon this bathroom here, come again fixed up. When the plumber came and removed the tiles and removed the thing, the plumber asked if anybody used to be in this bathroom. I said, yeah. Matter of fact, in the bathroom, you had to go to bathroom. And the man turned the inside of the water pipe and showed us. And him say, it's only by the grace of God we never go blind. Because what happened now, it was a metal pipe. And what happened is that the metal started to shed rust. And you had droplets of aluminum in the water. So you could get something, a piece of the shavings into your eye and you rub it and it just cut it up, bust up the whole of the blood vessel in your eye. And you could lose your sight. So I say all of this to say to you that, and Mikey, some of the septics don't have to be concrete or plastic. It could also be packed with limestone so that you can have the percolation of the liquid part of our waste to seep through or to infiltrate into the surface of the earth.
Yeah, I think NCU have a system like that,
Oh?
They have two NCU. They have two systems. So all right, so NCU water, it's the water that they have. It is treated through limestone. So they have this limestone filtration thing where it's collected and then I don't know how it works, but I just know that they have some limestone that treats the water and it goes to the tank on the field and then it's pumped to the different locations on campus. So that's how their thing works out. And they have one of those septic tanks that does that because there's a section on the campus. No matter how Manchester dry, it's always green. It's just there.
No. You're correct. There is and I've not seen it so often again, but there are places in Jamaica that it no matter how we're having a drought, see them lawn always green because it's irrigated water. And remember, it contains quite a bit of nutrients, so the plants will grow. The plants will grow. You remember in COVID when they say eat what you grow and grow, you eat and then fufu slogan there?
So I never said that long time.
Mm-hmm.
Yeah.
No.
More than COVID.
They said it more in COVID, but you see, they had some fertilizers that they were importing to Jamaica because they were encouraging us to plant more because we couldn't have the shipment of like our vegetables, mainly tomatoes, etc. And I remember one of the news class came and told us exactly what was in the fertilizer. And people start saying them not eating white man something because it's the fertilizer. So let me just give you like a piece of something. Mikey spoke about it, didn't go into the specificity of it. Let me just give you like a piece of what is happening. You see that solid part, the sludge? it is bleached. It goes through primary, secondary, and tertiary treatment to get rid of all the E. coli and the F. coli and all other types of bacteria. That solid part of our waste or doo-doo is then they add things like sawdust or polystyrene, you know, the little plastic cup, the hot tea cup and the coffin box that we drink out of.
Yes,
The one.
yeah.
Yeah. Those are crushed at times and mixed with the sludge. And then they add things like NPK, the nitrogen, the phosphorus, and the potassium. And that's what they call fertilizer. And it was one big thing because I knew from before that this is what it is. But the layman, them now, must never did understand what it is, and people now start talking about it, and they said them no want the fertilizer come because white man have this disease and that disease, and them can't eat the stuff. But I'm going to tell you, when you put those fertilizers under your tomatoes, it's the biggest tomatoes you get. The biggest tomatoes you get. So life is a cycle. That's the point I'm making. Sometimes I don't own a breadfruit tree.
Sorry, say I don't own a breadfruit tree. I don't want a breadfruit tree.
I don't own one and I don't want one.
Oh, sorry, bad what did you tell me?
Well, you have breadfruit tree?
Yes, sir. I love breadfruit.
Mm. Well, the truth of the matter is, I love breadfruit myself. I'll eat breadfruit morning, noon, and night. I eat it baked, roast, fried, boiled. I make salad with it. I love breadfruit. But guess why I don't like it? I wouldn't want to plant it.
Why?
I have a friend of mine who, her neighbor has a lovely breadfruit tree. And a couple of years later, she saw one breadfruit tree start planting off her yard, start growing off her yard. Because the roots of that tree is wicked. It runs, and it just pop up over the neighbor yard. Real talk. This is what it also does. It finds your septic and the roots embed in the septic. So see some people breadfruit tree, you get some lovely sized breadfruit off of it. It is the nutrients from what it is that we let out that is getting from it. Lots of people don't know lots of these things. And people squirm them face off of that. But when they get one big breadfruit and you get them, especially for yellow heart. And they say, Carol, I don't know about you, but just make it slightly turn. And then me start to roast that. I don't care. I will sit and I eat the whole breadfruit. You understand?
Yes.
But that's what happens. So I don't want it because it will find your septic. It will literally burst up your house, the rooted system, right? And this is why me think a breadfruit tree for plant a country and breadfruit not supposed to plant a keystone because the
sir, my
houses
breadfruit tree, breadfruit tree not really that big, you know. It narrow and it tall and the roots them thick and it fat. But the septic we don't really have like our septic thing now because it's a long time house is still good and upright, you know, sir. The septic they that wrong. It have like the other side of the house and they have this big iron thing over it. I have to literally lift it up and sometimes when it back up it will run out and then something there.
How close is the septic to the breadfruit tree?
Not close. Not that close to it, sir. Breadfruit tree that we run our back and one of the septic the other side of the house.
Okay. Well, don't be fooled if I tell you say that breadfruit tree already finds that septic.
Yeah, man. Roasting at that, man. Trust me. If you're supposed to do something pro, you're going to find roasting at.
Me not ask her, me tell her.
I want if I make you see Carolina, yeah? Don't make you fool, yeah?
No, I just
Carolina,
one. I just one. But I have to cut it down a little bit because it get the tree them I get too tall. I don't want to drop on the house.
But did you hear what Carol said? Carol said, and I don't know if you heard that the root of the breadfruit tree is big.
Yes, it's big,
It is
sir.
it is it is getting lots of
that's in the
nutrients.
dream. Yeah, man, that day in Nigeria, it's still out some
It's,
field roots in Nigeria already, man.
it is getting lots of
That's why I
nutrients.
have the backup problem.
That's why you're gonna have the macro problems. Real talk. Real talk. So that's the point I was making when I talk about the percolation and the infiltration from that septic, the liquid part is actually moving out. Now, one thing that Mikey didn't speak about, or did he? I think he did. Some of these septic, most of them, the ones especially when that are built, you build a house and you see the man go on and the man a building pit. That pit is lined with limestone rocks. Because limestone has a property of pulling the bacteria from the water source. So there are times when you look at some irrigation system and the signs are up and say water for irrigation purposes only. It means that the water would have gone through primary, secondary, but it did not go through a tertiary treatment. So it's not good for potable use.
Unless you disinfect the water.
You can drop some chlorine in there, but go ahead.
In Old Howard, there is the regular NWC water, and we have water from National Irrigation. And what we do, we mix bleach and disinfect the water. And I have a friend that if he's not testing the bleach, the water is not disinfected. So I think they get water twice a week, and that's how especially on the farm. So if you're like in Colbert area or you're along Bodles and out by Macooksen, yeah man, irrigation water.
Yeah, I'm aware of that. I am also aware of treatment of water with using the chlorine, but you see a lot of times, we don't know. We normally put 1 drop of chlorine per liter of water. You don't want to put more than 1 drop of chlorine per liter because
sorry, the water there we actually use 4% bleach and we dilute it to 2%. Yeah, that's how much chlorine we normally use to ensure that the water is sterilized for portable use. But trust me, it's still beautiful.
Yeah, it can work. It can happen. I remember in some recent hurricanes, in the last 20 years, we were having some water issue, and I don't even know if they call themselves Ministry of Health at the time, but coming from the authorities, they, were educating the public what to do with the water, because you had lots of animals got washed away, fowl and dog and rabbit and chicken chicken and fowl.
During Ivan, yeah man.
Right.
Good.
So
Yeah, man, and everybody learn how to drop one drop in a 1 liter, shake it up with the oil before you drink your water.
absolutely, absolutely. Yes, and it's because of the massive, loss of animal life, the pig and goat and all of them something there. So they had to do that in order to treat because NWC couldn't guarantee the treatment of all that water source because or the body because remember people had water people had water stored um in different areas. So they had to do what it is that they had to do in order for us to be safe. So it's very important. Very, very important. All right. I have I have pretty much gone through with you the water cycle. Mikey and I did this last time, so he's seen this a second time. I went through a little bit more in depth tonight. So it is, and well, this is not the diagram that we use, and I deliberately not use that one that he found for me. So it is that you can see what this water cycle is. Now, hear me out. If you were to go into the exam and they ask you to explain the water cycle, you need to give it a sketch of the water cycle. Personally, for me, when I was studying, I will study the water cycle because I understand the stuff. I understand evaporation, I understand condensation, I understand transpiration, I understand the whole business of deposition, precipitation, infiltration, percolation. I understand all of that. We just want to know if we put it in on something. So when we draw my diagram, then I just use the diagram and just explain what is happening. You can't give me less than full marks for the question. So you have to be very mindful if it is that they ask you to do the water cycle, that you do justice to the question. All right, I'm going to stop right there. We have 15 minutes to go. Are there any questions before I ask you to do something for me? All right,
No question for me.
All right, cool. So Asia, Karel, you last week Tuesday I'd given you something to do. Asia didn't have any internet and Karel apparently was sick last week. Do you still have the notes with you that you want to present now?
Sorry, when you say the notes, you mean like the time when we were doing like the acid rain and the stuff
Yeah,
where we got to
yeah,
present?
yeah.
Oh, okay. So I did a PowerPoint and I did like put
Let,
like
let me
videos
stop
in it.
sharing. Let me stop sharing. You can go ahead. You can share.
Okay. Okay. I'm going to share with you. Okay, everyone is seeing my screen.
Yeah, we see.
Okay. Okay, so what I was given or what I chose for my topic was acid rain. So this is my a little information slash discussion and my notes on acid rain. So first, what exactly is acid rain? So the term acid rain describes precipitation. So that's rain, snow, sleet, or hail that contains a lot of acidic substances, notably nitric acid, that is HNO3, and sulfuric acid H2SO4. It is created when sulfur dioxide, SO2, and nitrogen oxides, NOx, primarily from human activities like burning fossil fuels, are released into the atmosphere and react with oxygen, water vapor, and other substances. After that, these acids combine with precipitation and settle on the ground, known as acid rain. So for a far more visual, I have a video here.
Acid rain.
Y'all hearing it?
What is acid rain? Acid rain is any form of precipitation with high levels of nitric and sulfuric acids. It can occur in the form of snow, fog, and even dry materials that settle to Earth. Most acid rain is caused by human activities. When people burn fossil fuels, sulfur dioxide and nitrogen oxides are released into the atmosphere. These gases react with water, oxygen, and other substances to form sulfuric and nitric acid. Winds may spread these acidic solutions over hundreds of miles. After it falls...
Okay, so that's just the part about the acid rain I wanted you to see. The other parts aren't necessary for now. So moving on, sorry. So continuing. So acid rain, it occurs in two forms of deposition, and these are known as wet deposition and dry deposition. So wet deposition happens whenever snow, fog, mist, or acid rain hits the earth. The acid impacts soil, aquatic bodies, and vegetation when they break down into water droplets and fall with precipitation. This form of deposition has more immediate and a more widespread environmental effects. So an example of wet deposition is snow. And you know snow, so as the snowflakes would form, they trap pollutants such as like heavy metals, etc., as well as they can even trap radioactive materials. So when it melts now, eventually, these pollutants would be released into the environment. So that is an example of wet deposition, which would be the snow. And dry deposition now occurs in dry climatic conditions. So this happens when gases and particles that are acidic settle on the surfaces, like soil, plants, or buildings, without any precipitation. So it basically, in the name, wet deposition, dry deposition. The impacts of these dry pollutants can be delayed but remain detrimental if they are carried into water systems by rainfall. So one example of dry deposition is the dust that settles on surfaces. So these dust particles can settle on buildings, roads, and vehicles, and this over time, these dust particles, they can contribute to environmental pollution and damage to property. Next, we're going to speak on the formation of acid rain. So here we have another short video.
How does acid rain form? Acid rain is formed through a complex chemical process that occurs naturally. The process involves the reaction between water and other compounds like nitrogen oxides and sulfur dioxide. Acid rain chemistry. The formation of acid rain starts with the emission of nitrogen and sulfur particles into the atmosphere. These emissions can occur naturally through volcanic eruptions and lightning strikes. However, most of the emissions are man-made, as they occur when fossil fuels and other substances are burnt in power plants. The compounds from these emissions readily dissolve in rainwater in the atmosphere. When sulfur dioxide dissolves in rainwater, it forms sulfuric acid. Both nitrogen dioxide and sulfur dioxide undergo oxidation before dissolving in water. Once the acidic solutions are formed, they can be blown over a wide area by winds. After acid rain falls to Earth, it contaminates water systems and the soil.
Here is the video, and here is I found a picture of it for more visual impact. So here you have the man-made sources, and as he spoke about in the video, the natural sources of acid rain, which is as you can see here, is a volcanic eruptions and all of the gases that it's releasing into the atmosphere. And here you have the movements of the pollutants. Here you have dry and wet deposition showing. Here you have the particulate pollutants in the atmosphere, and then the pollutants in the cloud water and the precipitation, and you can see it's falling. That's when it would start to fall as acid rain. Yeah. That's for a more visual appeal. And next, we're going to speak on the impacts of the acid rain on the environment. So the impacts of acid rain on the environment. Oh no, sorry, not the. Yeah, we're speaking on the environment. So first, we're going to speak on it on infrastructures. So, for example, stone infrastructures. Marble and limestone are especially brittle materials. The water-soluble gypsum that results from the acids reaction with the calcium carbonate in these stones causes surface erosion and a loss of structural integrity. Now, this process can cause pitting, discoloration, and inscription loss on monuments, statues, and historic structures, among other apparent deterioration. Then you have metal components. Iron, steel, copper, bronze, and other metals corrode more quickly when exposed to acid rain. Bridges, railways, and pipelines are among the structures whose strength and safety are compromised by this corrosion, which raises maintenance costs and raises the possibility of safety issues. Then you have roadways and bridges. Acid rain induced concrete deterioration and metal component corrosion in bridges can result in structural flaws that pose a safety risk and require expensive repairs. And here is a picture. Here you have the stone, the monuments. You see it before and after the erosion of the acid rain, and here you have a bridge, and you can see the corrosion here. And here you have what it would do to trees, to land. As you can see, it's just basically one big stem, no leaves on it, nothing. So the impacts of acid rain on the water quality now. So acid rain has a lot of impacts on the water. One significant is lowering the pH level of the water, and this can lead to a lot of consequences, or like releasing toxins, harming aquatic life, etc. Everything. So here are a few. So as I said before, the lowering of the pH. The impact is that acid rain can lower the pH of lakes, rivers, and streams, leading to acidification of the water. Most natural water bodies have a neutral or a slightly alkaline pH, but acid rain can reduce the pH below 5.5, making the water more acidic. Consequences: this acidity can disrupt the natural chemical balance of water. making it more difficult for aquatic life to survive. Harmful to aquatic life, as I said before, the impact. A lower pH can be harmful aquatic organisms, especially those that are pH sensitive, such as fish, amphibians, and microinvertebrates. Consequences: fish eggs are particularly vulnerable to changes in pH, and acidification can cause fish kills. Species such as trout, salmon, and certain types of plankton may not survive in acidic conditions, disrupting the entire ecosystem. And as you know, some of us eat these species of fish, and that would be even more detrimental to us. Here we have other key impacts of acid rain on the water quality. So we have a reduced biodiversity. So different aquatic organisms have tolerance levels to the acidity, and this can cause a shift in the species composition towards acid tolerant species, leading to a reduced biodiversity. Impact on aquatic food webs. The loss of fish species due to acidification can disrupt the entire aquatic food chain, affecting other organisms that rely on fish as a food source. And lastly, the effects on plant life. Acidic water can also harm aquatic plants, affecting their growth and reproduction, further impacting the food web. As you know, that plant is the main source of food for for organisms. Here we have impacts of acidic rain on aquatic life. Further continuing, so acid rain can enter water systems as runoff, and this can make it extremely toxic to aquatic life, particularly affecting their ability to reproduce, causing deformalities in young, and ultimately leading to population declines or even elimination of certain species in severely acidic environments. So, as is mentioned before, it can cause this deformalities. So exposure to this can cause them to develop abnormalities in the fish larvae, leading to deformalities, and this can even lessen their ability to survive. So you also have egg and larvae mortality. Acidic water can prevent fish eggs from hatching properly, leading to high mortality rates among young fish. And you have, again, with the toxicity regarding the pH. Low pH levels can directly harm the physiology of fish and other aquatic animals, affecting their gills, disrupting their bodily functions, and causing death, particularly in sensitive species like the trout and the salmon, as we mentioned before. And yes, this is the end of my presentation on acid rain.
All right. I thank you. One of the things that I'm gonna say, and I think I said it. For all of you, I want you to. I'm giving you an opportunity to go and fix up these presentations that you did for me, and you're going to submit it. I'm going to be grading them. So I'm hearing the presentations. I'm hearing how it is that you've presented. I want you to fix it up. So I know Michael and Paz already presented. I want you to fix it up, your references, support, and so on. You're going to submit it to me. I'm going to give you a percentage towards your final grade for these presentations because you are doing the work. We are at the point in the chemistry and the environment where you are going to be doing lots of reading. Just like what I did with water cycle, I will go on and explain the stuff. I will come back to the acid rain situation for next class, God's willing. Remember, school reopens on Thursday. We only get in tomorrow, Wednesday.
Yes, sir, because it's Ash Wednesday.
Right. Now, one thing, Asia, you're going to go on Thursday, God's willing. Carol spoke about acid rain just now. What I want to leave the class with: nitrogen oxide, sulfur dioxide. Nitrogen oxide, sulfur dioxide. Nitrogen oxide, sulfur dioxide. You cannot be given a question on acid rain and you don't mention sulfur dioxide, nitrogen oxide. You can't be given a question on acid rain without making mention of those two compounds. Then, when you reference those two, as Carol did, you have to then explain what happens. It's to show you the building, how the acid rain eat it up. I've given examples already in class where in some parts of the world, the man might use an umbrella and appear holding the umbrella because of the effects of the acid rain. Agricultural crops, it mash up. And buildings, infrastructure, monuments, etc., etc. Bridges, after a while, the bridges will start to crumble. All right. That's where we're gonna end for tonight. Hear me out now, though. But you need to read. Read and more read. All right. Thanks for coming out.
Okay,
No
sir.
problem.
Good night.
Good night.
And have a holy Ash Wednesday.
To you, to my pops, and the rest of you.
Bye bye.
Yes, sir.